Okay, let's move on to section 10.3. 10.3, we've got some theorems here that we've got to knock down first, and then we'll move on to some examples. So 10.3, what do you think is true about minor arcs A, B, and CD? So in this one, I'm looking at A, B, and CD. Well, I think if you looked at that for a little while, and maybe if you measured and did some various things, you would find that A, B, and CD are congruent. In fact, we can say this: AB is congruent to CD, arc AB is congruent to arc CD, if and only if AB segment AB is congruent to CD, segment CD. Okay, so this all is based off this fact that AB, the segment, is congruent to CD, the segment. Okay, because those two things are congruent, the arcs must be congruent. Okay. Alright, let's move on. Theorem, next one. QS is perpendicular bisector of TR. What is special about QS? Alright, well, what is special about QS? Well, let me tell you. In Theorem 10.4 says this: if QS is a perpendicular bisector, running out of room, that says bisector, of TR, then QS is a diameter. Which means it cuts that circle in half. QS is a diameter. Okay? And that's it. That's all that theorem says. So if QS is a diameter, then we've got a number of things going on. We also know, well, I'm sorry, let's stop there. We'll go on to the next theorem where we learn some more stuff about this picture. So anyway, this also means this, that MT oops, I'm sorry. Gosh darn it. I apologize. We're moving on to the next picture. Okay. Down here, we've got all these questions and everything like that. And let's just, I'm not even going to worry about the question. I just want to tell you what it means. In this picture, we've got QS is a perpendicular bisector of RT. Okay? So we've got perpendicular bisector. We can say the following, that MT is congruent to MR. Okay? We can also, that's MT is congruent to MR. Okay? So those segments are congruent. We can also say the following, we can also say this, that RT equals 2 times RS. Okay? So if I wanted to go from R all the way around to T, those measures would be twice RS, okay? Implying that these arcs right here are congruent. Okay, so I've got congruent segments there, and I've got congruent arcs there. And I can also say this, that RS, arc RS, is congruent to arc, ST. Okay, so that's several things that I can say there. Let me give you the theorem real quick in math speak. Like I said, very quickly here. It says this: if QS is a diameter, if it's a diameter, we'll just abbreviate it there, and QS is perpendicular to TR or RT, okay, then arc RS is congruent to arc ST. And RM equals MT. Okay, and that's all it says. So that's theorem 10.5. Let's move on to the next theorem there. 10.6 is next. Okay. So we've got theorem 10.6. All right. And let's talk about it. In the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So if I have chord AB and I have chord CD, the only way that I know that those two things are congruent is if the distance from the center to the chord is the same. Okay, so if I've got a right angle and a right angle, and I know that the distance is the same, so that these two segments are congruent, that I've drawn in here. If that's true, then I know that I've got congruent chords. Okay, so it says this: AB is congruent to CD if and only if KP equals KL. And let me put in KP and L. So P is this point in the center, and we've got L right here. There's L, and P is this point out here. Excuse me. And K is the center. Frustrating, I know, I apologize. K is the center. Okay? And so that's it for theorem 10.6. Let's move on to the example over here to the right. Number 8. So, I want to find x. How can I find x? Well, I know that since the distance from E to this chord and the distance from E to AB, those are the same, right? Those are congruent segments. So I must know that these chords are the same. DC is congruent to AB. So to find x, I set these things equal. X plus 9 equals 3x minus 11. You guys, I'm sure, can do the algebra, and you'll get down and figure out that x equals 10. Okay? And x is 10. Alright, that's number 8. Let's move on to this example over here, number 3. QS. And I want to find QS, which is this whole length right here, from Q to S across from it. Well, I know that PR is a perpendicular bisector of QS since it's a diameter. Okay, so PR is a diameter. And that's important because I then know that these two segments here are congruent. So QS simply equals 11 times 2, which is just 22. Okay? Which equals 22. And that's it, because I know that this segment over here is also 11. Okay? And that's it for the first page, or set of examples there. Let's move on to the next one. One moment, please. Feel free to play the Jeopardy music or something else that entertains you as I switch to a different picture here momentarily, I promise. Let's move it in, move it out. Done. Here we are. Okay, number 4. On the back page now, or the next page, or whatever page it is in your packet. I'm going to, it's a back page for me, I want to find the measure of AC. Okay, so that means that I want to find the measure of this arc from A to C. The arc measure, which means my answer will be in degrees. And the important thing here is that I know that the purple arc and the blue arc are congruent. Because 7 is equal to 7, last time I checked, that means that these arcs must be congruent. Okay, follow my logic here. These two arcs are congruent. I know that the sum of the arc all the way around the circle is 360. Okay, so if I know that the sum is 360, and I know that one piece of it is 130, so measure of A, C, B, okay, that's A to C to B, that measure is going to be 360 minus 130, which will give me, what, 230? Alright, if I know that, oh gosh, sorry guys about the letters. If I know that, then I know that measure of AC must be half of that. So that must equal 230 divided by 2, which is just 115 degrees. Okay, so we're going to use some reasoning that's very similar to segments. Okay, I know the total is 360. Once I know that, I know that these two arcs BC and AC are the same, and then I can deduce the measure of one of them, AC. Alright, let's move on to the next example, number 2 here. Number 2, I want to find the measure of arc LM. Alright, well, if I want to find from L to M, and I know that all these segments here are congruent, that must mean that the measure of arc LM is going to be 360 divided by 4, right? That means, sorry, back up. I know that all these arcs are congruent, so I can put in little dash marks here. So I've got 4 equal arcs. And so that means that I can take 360, divide it by 4 equal pieces. The measure of arc LM must then be 90 degrees. Measure of arc LM must be 90 degrees. Okay, let's move down to number 9 here. Number 9 says this. I want to find X. Well, I know once again I've got this situation where I've got QS is a diameter. That means it's a perpendicular bisector of PR, which means that this segment here must be congruent to this segment. Or we could say this, 9x minus 3 equals 7x plus 5. And that's the setup on that one. Alright, so basically then it's just a solving x problem, right, which you guys know how to do. So you guys should actually do the algebra, check my answer here, and you hopefully will find that x equals 4. Okay? And that's how you would do number 9. Right? So we've got to use these theorems to our advantage, and I don't think there's any crazy results that are kind of mind-blowing. I think it's stuff that you would probably guess would be true. But anyway, let's move on to the next 2 examples here. I'll probably just do one of these, and you can do the rest of them. I'm going to do number 11. You should do 12 on your own. Number 11. Here's what I've got going on. I've got an application of that theorem, the last one, 10.6, and it says this: if JK is congruent to LM, if those segments are congruent, they're both 12, hint, hint, right here, so they're both 12. If that's true, then that means that N, the distances here, must also be congruent. In other words, 7x minus 10 must be equal to 3x plus 6. Okay, 7x minus 10 must be equal to 3x plus 6. You guys, once again, can do the math. You get 4x minus 10 equals 6. 16 equals 4x, and x equals 4 ultimately. Okay, so that's how you find x in that one. Do number 12 on your own. You're going to use this idea that those are all radiuses or radii to find x on number 12. Okay, so you're probably just going to have to set those things equal to each other, and hopefully should get down, and you're going to have to do the math here. You should get down to x equals 6, I believe, ultimately. Okay, so for credit on your notes, show all your work, and that is it for section 10.3, applying the properties of chords. Have a wonderful day.